we go with, excuse me, homework 4-8. We've got conditional probability. It says it's estimated 29% of adults invest in stocks, 86% have investments in fixed income, and 25% have it both in stocks and fixed income. Okay, so what I tend to do on this one, and I'm a visual person, so I need to see this stuff. So I put my stocks here, my fixed, what's over here? My fixed income investments or fixed income instruments. And then it says this is 29% and this is 86%. And in the middle, there's an overlap of 25%. So, then I'll read this question here. What's the probability that a randomly chosen U.S. adult invests in stocks given, here we go, given that he or she invests in fixed income? Okay, so when it says given this, that means I'm only going to look right here. All right, this is all I'm looking at. And out of that, 86% of the people, out of that 86% of the fixed income, what's the probability that they invest in stocks? Well, that's that 25% overlap. So I got a 0.25 over a 0.86. I typed that in my calculator. Knocks out 0.2907. And that's what I would put down for my answer. All right, let's try the next one. Clean up a little bit. So then the next one, it says, what is the probability that a randomly chosen stock investor? Okay, so basically that's saying that you're going to pick something from here. You're picking from the stock investors, so you're only looking here. So what is the probability that a randomly chosen stock investor also invests in the fixed income? So given this, you're only looking in this 29% right here. What's the probability that it also falls in here, which was 25, remember? So that's going to be 0.25 out of 0.29. Type that in my calculator. And I come up with 0.8621. 0.8621. That'd be my answer. So really, it's just getting used to these wording on these things, but you're going to isolate one of the circles and then take the overlap of that part of the circle that goes as part of your numerator. Play with those. If you need some help, let me know. This next one. All right, we got mutually exclusive events here. So remember what mutually exclusive looks like. Those events do not have any kind of overlap. Okay, those events right there are mutually exclusive. It says, suppose event A occurs with 60% probability. Event B occurs with 17% probability. If event A or event B occurs, what is the probability that a B occurs? Round your answer to 2 decimal places. If A or B occurs, what is the probability that B occurs? So remember, you got this event space that's got all the probability in it, but it says if one of these two, if one of these two occurs, which is it's a 77% chance, because I'm just adding those together. So together, these have a 77% chance of occurring. So that's if that happens. If one of these occurs, what's the probability it's B? So that's a 17, because that's B, 17 out of the combined 77. So again, 0.17 divided by 0.77. Type it in your calculator, get your answer, 0.2208. Okay. And last one here, intersection and conditional probabilities. Says, suppose that a certain college class contains 43 students, 28 are seniors, 23 are English majors, 7 are neither. A student is selected at random. What's the probability the student is both a senior and an English major? All right, so let's take a picture of what this might look like. So I've got seniors. There are 28 of them. There are English majors, and there are 23 of those. And then I got 7 folks out here that are neither an English major or a senior. And it says that this class has 43 students, okay? 43 students. So the question is, I got to figure out what's in this overlap right here. You know, how many people are both seniors and English majors? Well, there are, let's see how many people we got right now. We had 28 seniors. We got 23 English majors. And that number right there comes to 51. Okay, so this class supposedly has 43 students. Okay, 43 students. 7 of those I know are down here somewhere, not in my circles. So let me subtract them out. That's 36. That leaves 36 students that should be in these circles, right? I got 43 students total. 7 of them are neither English majors or seniors. So that should leave 36 students to be in these 2 circles. And that number right there, between 28 and 23, adds up to 51. So I'm going to take 36 from 51. That's a difference of 15. And that's telling me that this number, I got 15 folks that are overlapping here. 15 folks are overlapping. Okay, so that's really the key to this problem, is figuring out what goes in this little sliver right here. All right, so 15 of those folks overlap. So now I can answer this problem question that says, what is the probability that a student is both a senior and an English major? Okay, well, I know there's 15 of those folks. Okay, 15 out of 43. So I got a 15 out of 43 chance of being a senior and an English major. Now, next, if it says, given the student selected as an English major, so what you're going to do when that's given, you're only looking in this circle right here. Given, you're only looking at these 23 people that are English majors. Given that, what's the probability he's also a senior? So you've got only 23 people you're looking at. And out of that, 15 of them are seniors. So you got a 15 out of 23 chance of answering that question right there, given that the student is an English major. Again, just that circle, 15 out of those 23 are seniors. All right, so again, the key here is just finding this middle number. Once you find that middle number, these problems are pretty easy, but you got to do a little math, do a little arithmetic to figure that out. All right, so I'll be glad to help you with those if you need them. You might want to look back at this one more time if you're struggling with, see how I got that 15. See if, just replay it and see if you can, makes a little bit more sense the second time you hear it. All right, good luck, but let me know if you need some help.